Trigonometrical identities in simple equations. Our objective is to prove the relationships below. Look at the description. You need to be able to use the relationship tan theta is equivalent to sine theta over cosine theta, and sine squared theta plus cosine squared theta is equivalent to 1. We will start with the first relation. This is the coordinate plan. Point P has the coordinates x and y. This is the x and this is the y. This is a right angle triangle and this is the theta, and this is the radius, which is r. Looking at this figure, we can say that sine theta is opposite over the hypotenuse, which is y over r. Cosine theta is adjacent over the hypotenuse, which is x over r. And tan theta is opposite over the adjacent, which is y over x. This is the definition for the normal trigonometric relations. So if we have a right triangle and an acute angle theta, where x and y are the coordinates of the point P as it moves around the circumference of a circle with center O and radius r. As we said, the coordinates for point P are x and y. And OP makes an angle theta with the positive x-axis. Okay, now if we want to change the definition of the tan theta is y over x. Now we will introduce r. Notice that if we eliminate r, so we remove this r and this r, again it will be y over x. In the beginning, it was y over x equal to y times 1 over x. We can say that y over 1 times 1 over x. Now we multiply the r here and here, so we will have y over r times r over x. Y over r is the same as sine theta times r over x. Cosine theta is x over r, so r over x is the reciprocal. That means 1 over cosine theta. Therefore, sine theta over cosine theta. So, tan theta is equal to sine theta over cosine theta. We were able to know this by writing the definition of the trigonometric ratio. Then we introduced the r, which is the radius of the circle, in order to have the component of the sine and cosine. For all values of theta, except where cosine theta is equal to 0, so the condition is to have the cosine theta in the denominator. We know that as a fraction, the denominator cannot equal to 0. That is why we have the exception. And cosine theta is equal to 0 at 90 degrees and 270 degrees. That is for odd multiples of 90 degrees, where tan theta is not defined. Thus, we can say that tan theta under this condition is equal to sine theta over cosine theta. All of this is about the first relation. Now let's look at the second relation. Sine squared theta plus cosine squared theta is equal to 1. We will look at the same figure. We have the x and y component, and we have the sine, cosine, and tan as trigonometric ratios. You know from chapter 4 that the equation of the circle with center, the origin, and radius r is x squared plus y squared equals to r squared. While knowing that x and y are the coordinates for any point on the circumference of the circle. Using the equations at the top, so from here we can obtain the value of x and here the value of y. You can express the coordinates of P in terms of r and theta. We simply cross multiply. So x is r cosine theta and y is r sine theta. Now we can substitute. Since P lies on the circle, we can write x squared plus y squared is equal to r squared. Okay, now let's substitute. For the x, we have r cosine theta squared plus, instead of y, we have r sine theta squared is equal to r squared. Okay, now we will insert the exponent. So r squared cosine squared theta plus r squared sine squared theta is equal to r squared. We divide everything by r squared. We will have cosine squared theta plus sine squared theta is equal to 1. This is what we see here. Pay attention that when we insert the exponent, we do not write cosine theta squared. We put the power between the cosine and the theta to imply that all of this value is raised to the power 2. Thus, we proved that for all values of theta, with no exception, is cosine squared theta plus sine squared theta is equal to 1. Look at the book. Positive powers of trigonometric functions are written without brackets. As you can see here, because we have a positive power, there is no need for the brackets. But with the power before the angle, for example, cosine theta raised to the power n, where n is positive, it is written as cosine to the power n theta. We have another hint. We proved the relation cosine squared theta plus sine squared theta is equal to 1, which is sometimes known as Pythagoras' theorem in trigonometry.